Well, hello there, folks. So just to start us off, if anyone can name this tune, that you get an extra point. We know what points make. Anyway, so today we've got a slightly unusual one because Mrs. G asked what I wanted from the supermarket, and I said didn't know what to say. So I said, "Oh, how about biscuits I've never eaten before?" And so she said, "What ones?" I said, "Well, I don't know." So she came back with, just looks like a custard cream, doesn't it? But it's not any old custard cream, it's a rhubarb and custard cream. So we will see how that goes. Now, this week we're only going to have 2 lessons, then I'm going to put up some homework for you tomorrow. And then in the last week, which will be next week, we'll just have 2 again. And then I'll put up on the 3rd day a whole schedule of everything we've done over lockdown so that you can know really what to revise before the mock in September. But today's lesson is I really like this one for some reason. It's graphing modulus functions, and so you've got it's all about reflecting in axes and what happens there, which I just find quite enjoyable. So, and a little bit easier, I think, than what we did yesterday. So anyway, have a little look and see what you think. Right, so this is our topic for today, and let's just have a look at these 2 different situations that we've got to think about and what that's going to look like. So if you graph the function of x, then that's just a normal graphing. In this case, you're going to draw the graph as per normal, but then anything that would be negative you can't have, so it's going to become positive. So this is going to give us a reflection in the x-axis. So we're going to reflect in the x-axis and delete anything that's below the axis. Delete anything below the axis. So that's going to be our little mantra for that, or that's how we do that. So you probably want to write that down. Then what about this one? This is where we've got where the value is put into modulus form before you do the function to it. So that means we're only putting positive numbers in. So if we're only putting positive numbers in, we're only going to get the results when x is positive. So if I go to put x is minus 5 in, I'm going to get the same result as I would do if x was positive 5. And if you think about it, that means it's going to reflect in the y-axis. So it's going to reflect in the y-axis, but we won't be deleting anything this time because it'll just be doing that. So one which is like that would be y equals x squared. Because you don't get negative square numbers, that's going to give you the same sort of result, isn't it? So it's going to be things that look like that. So you can have y equals x squared minus 2. It might go below the x-axis, but whatever your y gets, you get over on the other side. So we're going to have a little go at some of those right now. So here's our first one where we're going to have to sketch x squared minus 3x minus 10 there. Then we're doing the modulus of that there. Then we're doing the modulus of the input into that same function just here. After what I've just said, you may want to pause the video and have a little go and see if you can do it. But what I would say is start with this. Start with the calculator. It makes life so much easier. So if we go into graph and delete that, delete that, then all we need to do is stick in x squared, take 3x, take 10. And when I hit draw on that, with your standard axes, it should look like this. Now, you can just notice that -10, that's going to be the y-intercept, isn't it? Which is what you see there. Now, you can mess around with it if you think you need to, but what's important when you do this, what they want to see is just where it crosses the axes, and you can do all of that with the G-solve on there anyway. But you'll also, that's just to make sure you know where you're going. But the first thing to do in terms of showing you're working and everything, you'll need to solve that, won't you? So if we solve that by factorizing, you've got, what's it, 5 and 2, yeah, minus 5x plus 2 is equal to 0. So that means that I know that the roots are going to be -2 and 1, 2, 3, 4, positive 5. Now, it doesn't have to be exact on the squares. In an exam you won't have squares anyway. They just want to know where these things are going through. And then we know we've got a happy curve going like that, and then we just need to mark on the fact that that's -10 there. And if they say any points where you mark the x-axis, then the axes, then we should really be putting that, and that in there to show that that's what's going on. Now we use that to do this. So what was it we were saying? We were saying, right, we can't have any negative results because the result of this is just going to be the magnitude of it. What's the size of the number, not whether it's positive or negative. So that means I'm still going to have what I had before from the 5, 3, 2, 0, and the -2. But this time, although that comes in there and that comes in there, all of this is going to be reflected up. Now I haven't really got enough room there, so I'm just going to make it up and say that if that was -10, that's going to be +10 this time, and then we're going across to there. Now if you needed to know that point, what that point was or what that point was there, all you need to do is complete the square. But they're not asking us to do that in this, but if you complete the square you can find the turning point, can't you? And that would give you what that point was up there. Now the last one, sketching the graph of when the input can only be positive, means all of our input's going to be like this, and then when I go to -2 I'm going to get the same result as if I had put +2 in. So for that reason I'm going to put my y-axis in the middle of my sketch this time, and I'm still going to be going up to 1, 2, 3, 4, 5 here, but when I get to -5 there, that's going to be my other root this time, and I still know that I'm going to be hitting the same point down there of -10. So we're coming, if we do it from here, then that's the easiest thing to do, isn't it? Just copy what I had there before and then go across and do the same thing up there. And if we just put in our points here, -5, 0, 5, 0, and we've got 0, -10 there. And over here I should also put -2, 0, and 5, 0, and 0, 10 there. Okay, and that's that one. Just one more example for today. I did say one more example, but actually there will be another one after this, so I'm afraid I said those words, but when I said them I lied them, to quote Dr. Seuss. Anyway, moving on. So we've got sin now. It's going to be quite difficult to squeeze all of these in this time, because we're going, our domain is -360 up to 360. So we are going to be, but you don't need much height on a on a sin thing, you just need to go from +1 down to 0. So if we want it to be quite small, if we just use 2 lines like that, that should work best. Now I'm going up to 360. How many squares have I got here? 1, 2, 3, 4, 5, 6. So if I do 60, 60, 120, also my 90 is going to need to be there, my 180 there, my 270 and 360, and then if I reflect that there, that should do it. Slightly off the right. So sketching that, now you can always whack this into your calculator if you can't remember, but the sin starts at 0, doesn't it, whereas the cos starts up there. So we are going like that, and then that's just going to continue down here and up here and to there. So there's your sine wave as per normal, and now we just need to think about what's happening there for this. Now this is the one where I do all of this and then I only want positive values, so I just want that, and these I want the magnitude of what that is. So when it's down at -1, that's going to become +1, so it's going to be a reflection in the x axis. So if I draw these axes again, that gets me that, and so I want all of what's above, so I draw those bits in first, and I've got another hump there, and then this becomes another positive hump instead of a negative one, and that's what we get on that one. And then when we come across to the last one, you might want to pause the video and see if you can do this one. This time it is the values that have to be positive that go in, aren't they? So if I start off by sketching my curve on the positive side, on the right hand side of the y-axis, then that's whatever that is going to be what my result is. So we are then going to reflect that, which will look about like that in the y-axis. Okay, this really is the last example. I'd pause the video and have a little go and see if you can do it yourself before I show you what's going on. Oh, by the way, whilst you're doing that, a little catch up on the rhubarb and custards. Steer clear, folks, steer clear. It's a bit more like eating sweets than a biscuit. I don't like to mix the two that much. I'm going to put them in the biscuit jar downstairs, and hopefully the children will eat them without noticing. Anyway, moving on. So this one here, where everything, you do the result, and then the result always has to be the magnitude, it has to be the positive. So I'm going to start by sketching this bit in, and then I'm going to be reflecting these bits up there and making sure that I put in any values of A, B, C, D or E where they change. So I'm starting off, I'm going to have my axes basically pretty much the same, except I don't need to worry about going negative this time in terms of my x, or below the x-axis. So I know that I'm going to have 11 with C still, and I'm still going to have -7, so I'm still got A, I've still got C, and I've still got B up here somewhere. Do recommend a pencil on this because it's easy to go a little bit wrong. So as those are the same, I do not need to, well actually I still should, shouldn't I? I still need to put in that is -2.5, 1.5. But then, this is going to continue down to 3, isn't it? So I've got 3 there, and that is point D. At this point it's going to go a little different. So it was going below, and there was a point E that was 6 - 5, so it's still going to be 6 on the x-axis, but the result has changed to a 5, so the y has changed to a 5, so it's then going to be reflecting up there and then coming down and doing something like that. And then over here we are simply going to be bouncing back up there like that. Have we got all? We've got A, B, C, D, and E all covered. And E, by the way, is now called E dash because that's not really E, is it? That's the only point that's changed on that one. And now if we come across to where the input is on the modulus, then I'm going to go for putting the y-axis in the middle, because my x value as negatives are effectively the same as my x values that are positives. They're going to give me the same result. So I know I'm going to have this 11 here, and I'm going to draw in everything that is on the right hand side of the y-axis, exactly the same as I did before. So that's coming down. It's looking a little different because I've just labelled it in a slightly different place. So it's still doing that, and I can call that 3, and that's D. I can call that E6 negative 5. But then I'm just going to be reflecting that over here. So that's going to go to negative 3. Like that. And that point there is a reflection of that one, isn't it? So that is D dash. And then this one is going to be, so if I make that look just about in the same place over there, that will be E dash, won't it? Which will be negative 6. Negative 5, and we'll be doing something like that. Okay, now all we need to do is have some practice. So we're looking at page 42, exercise 2e, questions 1, 5, 6 and 10, and they will also be on the video in a moment. Okay folks, right, well I'll be putting up some homework for you tomorrow as well, remember.